What about autonomous vehicles? The defects I showed you were just for normal vehicles. Well, in autonomous vehicles, things are going to get worse. And the reason is that machine learning is the heart and soul of a lot of these vehicles. And machine learning learns things that it has seen or that are somehow close to what it's seen. It learns by example. What we found is that machine learning can be brittle. Sure, if you learn one thing, you can generalize other things, but it is brittle in the sense that there are some dimensions along which small differences can result in big changes, or if it sees something unusual, it just doesn't even know what it is. There can be spectacular failures for the unexpected, even if it's something that a person would say, oh, I know that's a dog, or whatever it is. You can get completely random examples, and I'm having a little fun from the movies saying loaf of bread. But we've seen in operational systems that things are classified in ways that just doesn't make sense. Machine learning complicates safety engineering. Safety engineering assumes there's a thing called the V model, where the V is you have the requirements and the design down the left of the V, and the implementations at the point at the bottom of the V, and then testing goes up the right-hand side of the V. And it assumes that because that allows you to say, well, I know what I intended to build, and my testing can prove that I built the thing I thought I was going to build. But if you're doing learning by example, the left side of the V has a problem because you don't actually know necessarily what you're building. You're saying, well, I don't know what a dog is, I don't know what a person is, but I'm going to train it by example and it'll figure it out. Well, how do you know it figured out the thing you think it figured out? That's hard. It breaks the V because you lack traceability to an articulated design. Machine learning is also prone to brittleness to unexpected data variations, and we've seen that be a problem in autonomous vehicle safety as well. You have to ask questions like, were there biases or gaps in the training data? And it might be something like the size or shape of a person, but it might be the color clothing they're wearing. It could be a lot of different things. And how do you do assurance for rare objects and events in the real world? Safety is often limited by rare, high-consequence events. They don't happen often, but when they happen, it's really, really bad. And if you have a system that assumes, well, all the stuff that matters is the things we see most frequently, that's sort of at odds. Clearly, there are ways to try and deal with this in machine learning, but the point is that this is a difficult spot that requires a lot of attention to try and get safety.